So the incredible Forge Kitchen, Smokehouse and Bar have asked me if I would design for them another cocktail holder. Some of you all know that I've made several things for them before. I've designed for them a Scorpion cocktail holder for a sensuously spicy drink. So I've had a local profile cutting company cut out all the parts for me. It's mainly 5mm thick steel. Now I could have used my own CNC plasma to cut these parts out, but a 10 kilowatt laser gives you far more precision, and there's very little work to do my end other than putting a bevel on it. And bevels make parts look so much nicer. And to do that, I've simply got this tool. This is a pneumatic chamfering tool. I've put a link in the description, but essentially it's like a handheld router table. I'll show you how it works. There we are, so that's before, and that's after. Much better. I've spent about 10 hours, I think, just grinding all this lot. So I think now it's time to start welding it together. So let me quickly show you my new welding machine. This is the Simder SD4050 Pro. So it's a multi-welder, but it will do MIG welding, including pulse MIG, aluminium welding, and flux core. It's also a DC and AC/DC TIG welder, so we can weld both stainless steel and aluminium. It's also a stick welder, but all inverter welders can do stick welding as well. But it also has a plasma cutter with pilot arc, and for flux core and aluminium MIG, we can also accept a spool gun. So some of you may know that we've tested Simder's machines before. You could probably see the other rig that I've got in the background. And to me, they've proven to be excellent machines. But the main reason I like to work with Simder is because they really do listen to customer feedback. All of the negatives that I pointed out on the previous model, Simder has addressed in this new one. But as always, the deal I work with my sponsors is they give me a machine for me to review, I give an honest review, and then I give it to one of you guys for just £5. And just so you know, it's completely legal for YouTube because it's a proper competition. It's hosted in the UK and run by Raffles. So I might as well congratulate Tony Brown from the USA, who won the EcoFlow Delta 2 Max. Thank you very much, Tony, for taking part and supporting my channel. Links to the current raffle will be in the description. Right, so let's check out this machine, see if we can find anything wrong with it then. So welding is obviously extremely dangerous, especially to your lungs. So what you should always be doing is wearing a respirator when doing any kind of welding or grinding. Now, I actually have a powered air respirator that I built myself. That's because generally these things cost a fortune and I'm tight. So mine works by creating positive pressure in here. I just turn it on. So this is now delivering filtered air to my face, and it's pushing away any contaminated gases. I've done a couple of videos on this, so do check that out in the description. So I've got it mounted on my other workbench, which is closer to the plug sockets. If this is any good, I'll keep it on a welding trolley, but for now it's going to live here. So I've got my gas line plugged into the back. Let's turn it on and see what the display is. HF TIG, high frequency TIG, that's the one we want. So I think we'll start simply by TIG welding some 1mm thick steel. So I've gone ahead and converted my 3D model into a flat profile. And if we look closely, I've marked where the bend lines are. So once marked, I'll then go ahead and score those lines with an angle grinder. This is with a 1mm cutting disc. That way they become weak points that I can easily fold by hand. Until you get something that looks like this. So this is now ready for tacking up. Let's get started. Okay, so I've got my part ready. So I'm going to make sure it's got good contact with the table. These parts are curved, so I'm going to tack it and bend it as I go. Tack number 1. And the key really is to get that tungsten needle to be less than 0.5 mm above the steel. So I've had a little practice and I think I've nailed down the settings to just 20 amps. So I'll set this up and I'll zoom in so you can see the weld. There we go, there should do it. There we go, not too bad. Bearing in mind that this is only just under 2mm. So far, I'm really happy with how it's welding. It's been really responsive with the amp changes, and I'm really liking the pre and post flow gas settings. So the only thing that's left to do with these parts is to sand them up and get them ready for electroplating. I won't bore you with that. Let's just move on to the next parts. So I've just come to start making these parts here. But what I've just realised is I'm actually short by 1. Now, none of my lasers are powerful enough to cut 1mm steel like this. My plasma torch is not the cleanest way to cut something of this precision out with. I'll be getting out my CNC plasma shortly, but for this, I'm going to try another method. So all I've done is I've taken a regular printer and I've printed the part off. You might not be able to see it so well, but this is onto sticker paper. So I do labels and that for some of the things that I send off. This is just a spent page, so all of the sticky labels have been taken off. And I've printed the part directly onto this. So now this should transfer straight onto the steel. So I've given it a wipe with an alcohol wipe to start with. I'm try and get it as close to the edge as I can, and then lightly rub over the part. And essentially the ink doesn't stay on the sticky back paper, so it should come off straight onto the steel. See how that looks. Oh, look at that, perfect. Let me lift this up to show you a bit closer. There you are, that's a very fine line. That has worked out perfectly. So I'll cut this out by hand now using some metal shears. There we are, it's nearly there. I'm just going to use a chisel now to get rid of this bit and that bit, drill a couple of holes and file the rest out. Now these are awesome. I've got the Bosch one, which is quite expensive, but I've put a link in the description to ones that are similar to this if you want one. Ready for welding. That was a little harder to control because it wasn't quite as nicely set up as the laser cut stuff. You know, when it's all ground back, it'll look the same. Well, there they are. These are finished now. These are ready for electroplating. I think we can see we've got about 100% penetration, which is really good. Now, without doubt, a lot of you will probably be wondering, why on earth aren't I using gloves? I'm not being funny, the amount of gloves I would get through would be very expensive. Anyway, I'm a believer that dirty hands makes clean money. Right, so now I'm going to make some quick tooling for the hydraulic press that we built. I welded all of this together using Simder's other machine. Anyway, what I have are lots of these linkages. These were also laser cut and just beveled, but what I want to do now is put just a little dog leg, or a kink, by welding a piece of metal onto here, or tack welding it on, should I say, and another piece of metal onto the top die here. So for that, 2 tacks is all it needs. And I used about 120 amps. Right then, let's see if this works. Put a part in here. Moment of truth. Well, I'd say that worked perfectly. Just what I wanted. Oh, so satisfying. There we go, that's everything for electroplating. So we'll now move on to some stainless steel parts. First of all, I'm going to roll these to the right form. You can see I've added some paper tape to the rolls just to stop some cross-contamination from entering the stainless. There we are. And the thing about using rollers like this is they always leave little flat spots on the end here. But that's okay, we'll weld this together, grind it back, and then we'll put it through the roller again. So I've just set up one of the parts on a piece of scrap aluminium. The aluminium is going to act as a backer and protect the backside of the weld from oxygen. If stainless steel gets exposed to too much oxygen, you get something called sugaring, which isn't very nice and it's not food safe. So I'll try and get some close-ups of the weld, and I've also got a brand new ND filter for the camera. So hopefully you can see what I'm doing a bit more clearly. We'll start off with a series of tacks. Right, so I've moved the clamps around. I'm going to start at this edge. See how that looks. So it's a bit awful for me. Round about here I got blocked by the clamp, so I wobbled a bit unfortunately. If we flip it over though, you can see it's come out with just nice temper colours and zero sugaring. But that'll sand up nicely and we'll get it to a high polish. So I've just pre-sanded this one. As you can see, we've got a nice flat spot where the weld was. So I'll re-roll this and hopefully it'll be the right size. And that looks rather good, I think. Will the base plate fit in nicely? Should be a nice tight squeeze, which it is. So to fully weld this now, I've created a purge rig. You can see I've taped off all the holes and I've inserted a pipe around the back. So I've switched the gas on. This is now filling up with gas. And the line is just teed in from the main supply with just a little regulator. So the first thing I'll do is just put a series of tacks. So let's see how that looks. So far, so good. I'm pretty happy with how that's turned out. It has swelled here ever so slightly. So just using the butt of my hammer while it's hot, I'm just going to squash it down a bit. There we are, and when that cools, it'll actually pull it taut and go flat. And as you can see, just a bit of cleanup and it's done. So having it clean like that with very little oxide or sugaring means that very little bacteria will get trapped down there. So next we want to do the final assembly, but the parts in this raw steel state is no good. What I actually want to do is create an oxide layer, so that they turn out to be this colour instead. And as you can imagine, that's just by heating it up. And for that, I'll use my induction heater. So then, to assemble the legs together, I'm going to use the hydraulic press as a vise. There we are, she's not going nowhere. And I've got a trick to use the TIG welder to help me rivet these together. So first of all, I'm just going to do a little tack to hold that on. There we are, that just means it's hands-free now. And I'm very simply going to use the TIG welder to heat up the top of the tenon. So there we are, smashy smashy and job's a good one. So now we'll rivet this part on. We'll do the same again. Just 58 more to go. There we go. So now the electroplating's all arrived. Let's put these things together. So at this point you're probably wondering, what is all this just to power a little LED? So what I have here is a standard 9-volt battery, which I'd like to power this 3-volt LED. Now what looks to be a very complicated device on the back here is actually called a buck converter. You may be familiar with resistors. A resistor is normally what people use to drop voltages down, but you may or may not be aware, but a resistor actually produces heat, which means we're wasting the energy that we have in this battery. Now the restaurant wants these batteries to last as long as possible, so the most effective way of dropping the voltage down is to use a buck converter, which are over 90% efficient apparently. How do they work exactly? Magic pixies. That's as far as my understanding goes. So then, it's time for the appendages. Let's put a face on you. And so finally, that is them all finished. So now imagine this has been filled with dry ice. Smoke will be billowing out of its mouth and everything. Your cocktail arrives, lights on, ta-da! And you get to add droplets of the spiciness. And the idea also is that the waitress can pick it up by the tail and it's perfectly balanced. Look at that. Well, I'm pleased. What do you think? Right, so I'm aware that I haven't shown you all the features of the welder. So as a bonus, why don't we do that? So this plasma has pilot arc. That means you don't need to touch the steel in order to get that arc going. But anyway, this bar is 6mm mild steel. I've made a little mark here at about 150mm. Then what I've done is measured from the outside of this guide here to the other side of the plasma nozzle. Came out to be about 11.5mm. So I've scored a second line back here, which I'll then put this handy speed square on. And I've got the machine set to 50 amps and 5.5 MPa. Don't know why that's not going for it. And now the machine's turned off. Let me problem solve that. Right, so this is quickly turning into a slightly sour turn of events. What you just witnessed is me pop a fuse. That's easily fixed, and that's what we use in our UK plugs. And just for the record, we also use RCD trip switches. But now we're talking about fuses, I better highlight something that I was very disappointed by. And that is that the original fuses that come with the machine have been bypassed, as you can see with this piece of wire soldered onto the back. Now, believe it or not, this is actually a very common feature on a lot of Chinese equipment, and it's completely illegal. The whole purpose of a fuse is for safety. These blow before your wires catch on fire. Now, I actually approached Simder about this problem, and they assured me that they weren't going to supply these bypass fuses anymore. However, this is the second machine that I've received from Simder that now has that problem. I understand why they add it. It's so that people don't have to change the plug like I'm about to do. But if they have just supplied it without a plug at all and just the lead, they would have been more trustworthy, I believe. But anyway, let me show you my fix. That is simply snip this off. And I'm going to simply add a 32 amp blue plug, which is what most single phase welders use. Right, well, see how that works now then. Right. That was better. I'm going to change some of the settings and take another cut. Well, that was a much cleaner cut, but it wasn't very straight, and I've wrecked the tip a bit as well. I think I'll try that again. Let me change the consumables and see if we can cut something thicker. Alright, so I've now got some 10mm thick steel. Take it nice and slow, shall we? you can see, it's certainly cut through, although be it on a funny angle. A bit of dross on the other side. Hopefully that just comes off. Oh yeah, nice and simple. Okay, well so far that's pretty good, I think. So then we might as well use the MIG function. I've got my Parker 360 amp torch plugged in. It does come with a torch, but you know, I'm going to probably flog that on eBay or something. And after consulting the manual, realising some of this is probably done in Windows Paint, I need to put the earth clamp into the negative and this funny auxiliary lead into the positive. Anyway, we're at 200 amps, 15.6 volts. Right then, mind your eyes. Right, it's not very powerful, is it? Try that again. I've increased the volts to 25 volts. Well, anyway, let's put an ND filter on and see how that goes. There you are, not too bad. So basically this is on its highest setting. Now I have also turned up the inductance to 10. Let's try putting it on 0 and seeing how it looks on this side. So lots of spatter, but it looks like a very good weld. It's got a nice shape and profile to it for sure. I'll cut that open in a moment. Let's try something else. So if I was on mixed gas, let's try, pulse MIG. Yeah, that'll do. Let's try that. Mind your eyes. Oh, it doesn't sound right. Let's have a look again. Zoomed in. Let's put the cap on. I was not loving life. I've turned it down to 20.5 volts. Now that is not strong enough at all. I'm turning it up again. 25 volts, 200 amps. If I turn the inductance down. Turn the inductance up maybe. Now that just did not love life. So you can see this bit here is 20.5 volts, 200 amps. Anything above that, it goes mental. Now this setting is actually meant for aluminium MIG, so maybe you should try that instead. Right, so this is a random piece of aluminium. I'm not sure what the grade is. Let's see how it cuts. Answer, cuts beautifully. I reckon I could go quicker than that as well. Well, let's clean these bits up and give it a go. So for aluminium MIG, I bought this spool. This apparently is the ER5356. I don't normally use this stuff, so I only bought a little one. And you may notice that this doesn't fit onto this spool holder. But that's okay, this actually comes off. Right, so that does fit on there now, like that, but I just realised I don't have to do this. I've got something called a spool gun, so we'll try it on that instead. So here we go, here is Simder's spool gun. One of these is ideal because the aluminium is very soft. Therefore, when it goes through, say, a long lead, it's going to crumple up and make what you call a bird's nest. So to have the wire as short as possible before it comes out the nozzle means that we stop any of those problems from happening. And just for reference, we've got it plugged in exactly the same way as we have the MIG, except we've now got a button switch that plugs into this slot here. Now, if you're like me and rarely look at instruction manuals, that little switch there will most likely catch you off guard. Make sure it is switched to spool gun mode. Cleaned up the parts. So let's give this a shot. Nothing yet. Again, I've bumped it up to 30 volts, 200 amps. Wow. Forgot to change the gas over. Needs pure argon, not mixed gas. That could be the issue. Let's try that again then. Having the clamp a little closer. that is just not working for me. Right, I've not had any problems like that with their old model. Their old model worked really well. I'm going to do a quick bit of research, see if I can figure out a problem with it. Okay, I think I figured something out. So if we first prep that to be there, and then with aluminium it actually helps to preheat it. And there we have an aluminium weld. Except I didn't do this with the pulse MIG. This was on the 100% argon setting. And something that's a little bit frustrating is I can't independently change the wire speed. That automatically changes when I raise the amps. I can change the voltage, which changes then the stick out. But there you go, it can still do aluminium MIG, or just haven't figured out the pulse setting yet. Let's try TIG again and see if we can unlock the aluminium settings on here. Let's say 120 Hertz. And it's in the AC balance to about 40%, I reckon. That, to me, should work. So I've got a 2.4 white tip tungsten. This is a number 12 gas lens as well, by the way. And for those that are interested, this is the filler wire that I'm using. So, let's have a little go. Alright, so for reasons I can't figure out, I can't get it to work. The soot suggests contamination, but I have actually cleaned it. To prove a point, this is what I was doing with the Jasic model. Now, I haven't got years of experience with aluminium, but I do know a little. And obviously on the same piece of metal, I tried another test, and as you can see, it's like it doesn't want to melt the oxide at all. Now, I had sharpened the tungsten, and so I really don't think that was the issue. It's definitely an aluminium compatible tungsten as well. But even still, if things are a little bit dirty, I should still be able to get a molten pool that goes nice and shiny. And for whatever reason, I just can't seem to be getting it with this. So now I'm going to perform a literal acid test. Neutralize that. Right, so here we go. This is our MIG test. And looking very closely, we're not actually getting much root fusion. In fact, that hasn't really bitten into the metal at all. You can see that these lines are still very straight. A way to get around that would be to preheat the metal first, make sure there's lots of heat into it. Otherwise, I'd say that these cheap MIG welders are only good up to about 6mm or 8mm thick material. I mean, that looks pretty good for a few projects, but looking at the penetration, I wouldn't trust that for anything structural. Now, I haven't got anything to etch aluminium, but a good indicator is where that little line down there stops. To my eye, it stops about halfway through the material, which means it's got good penetration. A definite bad spot, though, is that little hole just there. It's called porosity, and that's not a good thing. That can cause a crack. But otherwise, I'd probably want to have filled that a little bit more. It's a little bit too convex. So in a nutshell, what do I think of this machine? Well, quite honestly, I actually prefer their old machine. The only problem that I believe this machine had is that the plasma torch didn't have a pilot arc and it was really rubbish. But the pulse MIG and the synergic MIG functions were absolutely spot on. And the etch testing we did previously definitely outperformed this model. And for whatever reason, I can't get the pulse function to work properly on this one like it did on that one. The plasma, the DC TIG, and the MIG welding function is absolutely ideal on this. I have no doubt the stick welder will be absolutely fine also. There's literally nothing to a stick welder, it's just a power supply. There are, however, some significant flaws with this machine that you need to be aware of. So this is the first machine that I received. This is actually the second one. That's because I had several things wrong with this one. So firstly, down here, this is your module for the high frequency. It runs both the plasma and the TIG welder. So mine came with wires that weren't even connected. That wasn't a big job, I was able to reconnect them myself. So for me, I'm used to tinkering with cheap stuff. But I think for most people that would have been incredibly frustrating. And I have no idea how good Simder's customer services are. Now on the front of the machine, we've got the positive and negative connections very close together. And so what happened with me is I had it wired incorrectly. I plugged the wrong wires into the wrong area. And so a high frequency arc actually jumped across those two connections. Hence why I've added this rubber hose just to help with the insulation. Fortunately, that didn't cause a fire, but it could have very easily. So I had repaired it again and all was working fine until I got the plasma torch wires the wrong way around again. The TIG welder still worked fine, but the plasma just won't operate anymore. If I could find and replace that part, I probably will. And when I relayed all these problems to Simder, they were very, very apologetic. I mentioned all the problems and they assured me that they were going to diagnose it and make sure that problem wouldn't happen again, especially the bypassed fuse. But when I received the new unit, it came with a bypassed fuse. So if you can afford to lose 600 quid, it's probably worth it. For 600 quid, I would have snapped this model up in a heartbeat. But with all the problems I had with this one, I have my doubts. But I'll give you a long-term review because I intend to use this for a lot of future projects. I've got a very large hot water tank to build. I've also got an aluminium sidecar for an e-bike, and I've got all the developments for the new gasifier. That's to turn wood into sustainable power. So don't forget the raffle. Simder will be providing a brand new unit there. And in the meantime, can I recommend this video? And until next time, I hope you can get out there in the real world and forge for yourself a life worth living. See you in the next episode. Bye-bye.